All right, we're gonna be YouTube famous today. I'm gonna start recording for the people that aren't here, just because this now ties into the lesson and motivates what we're doing. So I'm gonna start playing some catch up with you guys. If you still like doing the area model, you can still do area models. What's the four multiplications? Minus 1x, x squared, and 1. And then when you add those two together, you get minus 2x plus 1. And then you distribute the 4. And then you collect the like terms. 4 minus 1 is 3. So yay us, we did it. So my question to you guys, so clearly we graph the function in vertex form. Vertex is 1 minus 1, step patterns over 1 up 4. So clearly it has x-intercepts. They're not at nice like corner points where we can read them off. We kind of have to eyeball it. It looks like maybe it's 0.5, maybe it's 1.5. We kind of have to estimate because they're not at integer values. So I'm just going to make a brief note about that. I'll try to keep it concise for you guys. Let's go 20. Since the x-intercepts aren't integers, like whole numbers, we have to estimate from the graph. So maybe, like the first few days of the course, graphing from vertex form, maybe like we found x-intercepts that way. We graphed the vertex form and we just read off the x-intercepts. Well, we can't read them off here. But now we have another way we could find x-intercepts. Maybe we can try factoring this guy. So while I pass around the next thing, my question to you guys is, can you apply the factoring techniques that you used in the warm-up and from earlier lessons to factor 4x squared minus 8x plus 3? So can you guys try factoring that while I pass around the next thing? Ignore the last sentence and then maybe
Why'd you notice that too?
All right. Let's. It's not a simple trinomial, so let's try applying our various methods. We have 4x squared. We have 8x. Maybe I can divide by 4. Can I divide everything by 4 though? No, 4 doesn't go into 3. Maybe I can use one of our special patterns. 4 is a perfect square. Is 3 a perfect square number? No. So for the 3M people, currently with the stuff you've learned in this course, we cannot factor that one yet. For the people that took 2D last year, we haven't reviewed any methods that you can use to factor that yet. But clearly, there are x-intercepts, so how can we find them? So today we're learning one last technique that is going to help us find zeros, or at least factor for now, in these scenarios where the a value is not 1, but we can't use any of our common factoring or special patterns. Okay? So let's dive in to the lesson. Now, I do have to give a bit of a preamble here. Today we're factoring complex trinomials. So complex trinomials have an a value that isn't 1. You guys already have a method, 2 methods that sometimes work. Sometimes you can divide out the a value like in the warm-up. Sometimes you have special patterns. But we're looking at trinomials today where we can't do either of those things. There are many methods for doing this. You guys in the back, you guys listening? This is your last chance to work together before we move things around. Okay, you got to be dialed in. There are many methods for factoring complex trinomials. I'm going to teach everybody one today. If you learned a method last year that you're comfortable using after grade 10 academic, then you can continue using that. That's totally fine with me. But this is the method I think helps most people most of the time, considering the spectrum of students we're all teaching in this one room together. So preamble done. Let's dive in. As a motivation, can you guys, just one more time, can you guys expand a couple binomial brackets? This one for the 3x might look a bit different. We've got actually the 2x inside the bracket there, but you're still just doing your 4 multiplications. Can you guys expand that for me? Your 4 multiplications, and then collect the like terms. I'll even make an area model over here if you like those still, because we got lots of room. So we got 2x, we got plus 3, we got x, we got plus 5. So we're going to have a 2x squared. We're going to have 3x. We're going to have 5x. No, excuse me. I know what 5 times 2 is. 5 times 2 is 10. And 15. So whichever way you slice it, you get 2x squared plus 3x plus 10 plus 15. And then you collect the like terms. 2x squared plus 13x plus 15. You guys get that too? All right, so we're asking the question today, what if you wanted to go back in reverse? What if you were given 2x squared plus 13x plus 15 and you were interested in factoring, so say that you could find maybe some x-intercepts. So the question today is, how do we reverse this process to factor if we start with 2x squared plus 13x plus 15? How can we go backwards to get 2x plus 3x plus 5? Because this trinomial, we can't do any of our previous methods, right? 2 does not go to 13 or 15 evenly, and 2 and 15 aren't perfect square numbers. So I'm going to ask you guys the question. The key is these two numbers, 3 and 10, is kind of the key. So my question to you guys is, how can you arrive at the numbers 3 and 10? If I just gave you 2x squared plus 13x plus 15, what is special about 3 and 10? So I'll let you guys have a think on that. The people that took grade 10 academic, you might remember the connection. For the 3M people who took grade 10 applied, this might be new. But see how could you pull out 3 and 10 if you were just given 2x squared plus 13x plus 15. And then I'll show you how we can proceed to factor it. It's a bit of a hint. It's kind of a similar numbers game to what you guys have done with simple trinomials. If our starting point was here and we work backwards, why 3 and 10? Why not 4 and 9? Why not 5 and 8? Why not 6 and 7? What is special about 3 and 10? Anybody either see a connection, Sullivan? What do you think?
Do you multiply A and C and then find the common numbers?
So, if I can summarize what you're saying, possibly.
So like 2 and 15, and then find the common numbers between 13.
So 3 and 10 add to 13, but you're saying it's not 4 or 9, it's not 6 or 7.
Well, 3 times 10 is 30, which is the same as 2 times
3 times 10 is 30, which is the same as 2 times 15. That's the connection. You're exactly right. So the big idea for today, guys, in order to factor this last level of quadratic function, and so if everybody would jot this down. So again, we're currently review mode. 20, please. There we go. We're currently in review mode for the people that took 2D, or this might be new for the people that took 2P last year. All right. To factor, these complex trinomials, look for two numbers that, so this is similar language as to with our simple trinomials. So two numbers that, one, add to b. So the middle term where you guys are used to looking for numbers that add to, it's the same idea. And multiply to not that last number c, instead the product a times c. So if you guys could just get that down, we're going to put it into practice and see how that works. Similar numbers game with simple trinomials. We're looking for numbers that add to the middle term, but not multiplying to the last number. Like Sullivan said, they have to multiply to the product of these two numbers. So we're going to apply this rule many, many times today. It's your first time seeing it. It'll sink in. And then, but honestly, for a lot of the grade 10 academic people, you didn't exactly master this last year. So it's like a second chance to get good at it. All right. Let's see how this rule works with the one we just did. And I'll walk you through the method I like to use called the Australian method. Later, maybe, we'll learn a more classic method. I think the people that took grade 10 academic last year might have used decomposition. I'm a fan of the Australian method. What's the Australian method? I'll show you. All right, so we're factoring 2x squared plus 13x plus 15. We have this mantra in our head. We look for two numbers that add to 13 and multiply to the product of 2 and 15, which is 30. Now, you guys have been doing this over and over again the past few days. You guys have done a lot of these, so hopefully we're getting pretty quick at identifying the pairs of numbers that work. The two unique numbers that work are 3 and 10. But what do we do with those numbers? What we do is we set up a skeleton that's going to help us create our factored form. And it works out the same way all the time. You have two brackets. This time you put, because our a value is 2, you do 2x and you do 2x. And in addition, you put a 2, and this is where the Australian method gets its name, because you put the 2 down under, as they would say in Australia, right? So you get the joke, Australian method. You also put a 2 down under. That's the last time I will attempt that. And we take our two numbers, 3 and 10, and we stick them in these brackets, plus 3 and plus 10. And we are almost done. That was it. I like this method because it's very similar to what you guys have already been doing. You find your two numbers, you stick them in brackets. The only new thing is that we're dividing by 2. So how can we clean this up a little bit? I don't like to see that divided by 2. Can you guys look at these brackets here? Is it possible to divide one of these brackets by 2? It is, right? This one, we can divide everything by 2, right? 2 divided by 2 is 1. 10 divided by 2 is 5. I'm going to show an extra step here illustrating what we're doing. So that first bracket, 2x plus 3, we can't really do much with. We're just going to leave it as 2x plus 3. But for that second bracket, I can divide a 2 out of each term. And I'm going to put the 2 out front, and we're left with x plus 5. When you divide 2 from 2x and 2 from 10, everything's all divided by 2. And then this always works. It's a nice self-check with this method. If you've done things correctly, the number on the bottom will always divide out perfectly. And so we're left with our factored form of 2x plus 3 times x plus 5. And everyone, is that not what was at the top? What we expanded? Yeah, it works. So there's pros and cons to this method. I'll list the pros again. The pros are we're just doing things, the skills, you guys kind of already have these skills. You've already played this numbers game many times in this course, both classes. You have the skill of common factoring, of dividing out what we can, and then it's just a bit of canceling. I think everybody can do this, and we have a self-check built in on to know we've done it right. So that's why I like the Australian method. The downside is, why does it work? This might seem a little bit of hand wavy, and I can agree with that. It's kind of hard to see why it works. Once we're in the lesson, I will show why it works on the sideboard there if you're interested. But yeah, it works. Yes, you got to go. Nina, there's enough practice on the actual document that you can just do that. Okay. All right. Now, like any factoring question, have a good weekend, Nina. You can check by expanding. We already did this actually. We already did this. We did this up top. So I don't think it's a good use of our time to expand it again. But now that we've seen the rule, we just need to practice. We're going to do a few more together with this guiding structure from me, and then we'll kind of gradually release the responsibility to you guys to try some more with less guidance, and then independently do these without any structure. So let's look at example 2. 3x squared plus 11x plus 6. Applying our algorithm, you want to find two numbers that add to 11 and multiply not to 6, because it's a complex trinomial, but multiply to whatever 3 times 6 is, which is 18. So two numbers that add to 11, multiply to 18. You've probably already done this exact same numbers game before, but if you want to in the margin list the numbers that multiply to 18, totally welcome to do that. And we can see we're moving a little faster now through our factoring problems because we've done many. 2 and 9 fit the bill. 2 and 9 are those two numbers. And so we set up our factored form. 2 brackets. This time, because the a value is 3, it's 3x, and then 3 down under. Then you plug in your two numbers, plus 2 and plus 9. And now we look for, hey, can I divide something out of any of these brackets? You guys see the one you can divide something out of? You can divide a 3 out of that last one. So we have 3x plus 2. You can divide that second bracket by 3. You're left with x plus 3. And this nice self-check, right? The 3 on the bottom divides with the 3 on the top, so we know we did it right. We're left with, I don't like you, go away. 3x plus 2 times x plus 3. And I've been a little naughty here. I have not been using my equal signs each line. So I'm going to start being a better person and using my equal signs. I truly believe everybody can do this. It's the same algorithm every time. You play the numbers game, you find the two numbers, you set up your skeleton and stick the numbers in there, and you're almost done. Little bit of dividing, everybody can do it. I truly believe that. A second one in the books. Anything you guys want to chat about? Let's try another one. This one has a little bit of a twist, not a huge twist. I think this one has a twist. Let's begin. So 6x squared minus 11x plus 4. Can't divide it to 6. Not a perfect square. So that's okay. Find two numbers that add to minus 11 and multiply to whatever 6 times 4 is, 24. I recognize both of those numbers will be negative because they multiply to a positive, add to a negative. And then you just got to find the numbers that work. I know many of you guys will have found them already, but you can brainstorm in the margins. You can take out your calculator and just start dividing 24 by random numbers so you find something that works. But 3 and 8 can make minus 11, right? If they're both negative. So 6x minus 3, 6x minus 8. So far, so good. Set up our skeleton, 6x, 6x, 6 down under. But can you guys divide a 6 out of 3 evenly? No. Can you guys divide 6 out of 8 evenly? No. So what do? We can divide something from this one. Gordon, what can you divide from this one?
3.
We can divide a 3 from this one and a 2 from this one. Let's do that and then see what happens. So 6x minus 3, we recognize, hey, I can divide out a 3 from both of those numbers. I'm left with 2x minus 1. From 6 and 8, I can divide a 2 from those, and we're left with 3x minus 4. And we still have our 6 down under. But the guys, that self-check still holds. 3 times 2 on the top is 6. 6 divided by 6 is 1. And everything divides out nicely. And we've done it. We've factored to 2x minus 1 times 3x minus 4. So it's the Australia method. That is the highest level of complication you guys could come across, where you can't take an actual 6 from each one, but you can take something, and those two somethings will multiply to 6. I can also, if you're feeling good so far, I can basically tell you the shortcut. The shortcut is when you're at this step here, just divide by whatever you can. Divide this one by 3, 2x minus 1. Divide this one by 2, 3x minus 4. It works. I will continue to show this extra step. We've now done 3. We're really getting to the point now where I'm repeating myself. Can you guys try the next one? And then we're just going to shift into basically just doing a bunch and trying to get better over today. I think this method is new for everybody. If you did decomposition last year and you're really good with that, by all means continue to do decomposition. I like this method. So add to 18. 5 times negative 8 is negative 40. You know what else I like about this method? I like a lot of things. In case you couldn't tell, I like this method. Everybody in the room can set up the factored form without any thought. It's 5x squared. So you do a 5x bracket, and divide by 5. Everybody can do that. No thinking involved. Also, our two numbers multiply to negative 40. So you guys can all get the signs in here without any thought, plus and minus. So it gives everybody at least a starting point to jump off from, or a point where they can now just, they've moved the needle. You could try a bit more, get more par marks. Whereas decomposition, for the people that took grade 10 academic, sometimes people just can't even get started. What are our numbers here? So 1 and 40, 2 and 20, 4 and 10. Which ones differ by 18? 2 and 20 differ by 18. And they have to add to positive 18. Did you guys get 20 and negative 2? 20 and negative 2? Nod and smile, 20 and negative 2. Next step, you will always, always, always be able to divide something out of one or both of the brackets. Here, it's just 1. It's nice when this happens. I can just see that 5 divided by 5 is 1. 20 divided by 5 is 4. You know what? I think I will tell you guys, I think everybody in the class, not exaggerating, in a question like this, you could probably just go to the answer if you can recognize 5 divided by 5 is 1 and 20 divided by 5 is 4. You can just go right there. I will continue to show the extra step of, okay, we divide that 5 from x plus 20. We're left with x plus 4. And then your 5 divided by 5, that's what's left. But I really think I think many of you guys could just skip that step. All right, you guys took that like champs. Complex trinomial factoring, not everybody's cup of tea. It's one of the more complicated things we do in the course. It's all just algebra. So you guys are doing really well. But we got to master this. So we got to practice. That is what today is for. We have 35 minutes to just get better and better and better using this method, and with less and less and less guidance from me. So here is 4 more with the structure, and then 6 more without any structure. I'll have them all taken up before you go, but now it's kind of like you guys start working and practicing and working with each other, and we'll take some up a bit at a time. Okay? Washer? Right on schedule? You guys now are giving these a try. I won't leave you hanging. I will take these up, but now we're moving in towards more, can you do it independently? If you want to rotate a desk or move with some people, it's totally fine. Make a group of 4, as long as we're productive. But yeah, let's practice, practice, practice. We got to be good at this. Don't make me regret saying turn your desk around and work with people. Let's get some practice done. I'm going to take up the first one and then tour around and help out. So everybody can set up 4x plus 4x and 4x over 4. Multiplies to 12, adds to 13. Somebody who hasn't helped out yet today, what did you guys get for your 2 numbers? Jaden. 12 and 1. Plus 12 and plus 1. And then you look for things you can divide. I'm not going to be I'm not going to make things with crazy big numbers you guys can't do with your current numeracy skills, but yeah, 4x plus 12 we can divide out of 4. And the 4's divide out. And then the last time I'll say it, I am totally okay if you can recognize how the dividing is going to work out and you can go right to your final factored form. That is okay with me. You have my blessing. All right, I'm going to tour, help people out.
Oh, wait.
If you finish all 10 on this, let me know. I just have more practice to give you. And then, as I said, Monday we get another day. The 3M people get a day to do an assignment on this because it's new. And the 3U people get a day to work on this and what we did yesterday. Nice day to practice. Can we send one of these out?
Yes.
Sure. Yep, and then it would be minus 3, right? So before we even do the numbers, can you set up what that step would look like? Perfect. Like, is that going to be done super quick? And then because they multiply to negative 12, 14, you know that once plus equals minus, you can fill that in.
Wait, no.
Yeah. And now you just gotta take a minute and see if you can figure out what the 2 I'll have it taken up in a sec. Yeah, it looks like it. What do you prefer, decomposition or this?
Yeah, that's what I was thinking. The other side, I can't do it.
Do you remember decomposition from last year? Okay. Well, just keep using this one. It's better. Collected, okay? All right. Let's see what we got here. So don't pick it up. You set up what you set, right? Actually, you're almost done. So 2 brackets. Set it up. Okay, and because we're doing complex trinomials, it would be 4x and 4x.
Okay.
Yep. And then our new method says we also need 4 after the bottom. Sure. And then you'll always be able to divide one or both of these brackets by something. Emily's got it, so I'll let you call them. But very good. Keep up the good work. You guys doing okay over here? You guys will be fine.
Guys, why don't you slow?
Yeah. You guys gotta slow down. Do you remember decomposition from last year? Kind of. What are your initial thoughts on this method? How did we do?
Would these be numbers or would they be different?
They would be different because they have to multiply to minus 12. So, but always start with the 1. That's like, so 1 times 12, right? And then you actually don't have to go any further because 1 and 12 are off by 11. So 1 and 12 are going to be our numbers. Yeah, and because they have to add to the positive 11, that bigger number has to be And then now, before, you couldn't divide a 4 out of 10. But now you can divide a 4 out of 12. What's 4 divided by 4? Or sorry, 12 divided by 4.
4.
You have a calculator? Okay, yeah, so that. And then you're basically done. See how the 4 divides by 4? Yeah, you're doing great. Let me get that one up on the board too. Okay, I'm gonna get the second one taken up and then tour some more. All right, I think I'll pause the video now and then just post a filled in note.